first thing I'm going to do, I'm going to put on some gloves. Does two things. Number one, of course, it protects the component. I don't want to get oils and stuff from my hands on the component. I'm going to go through a lot of trouble to clean everything, to make sure it's nice and clean, so we get good, reliable joints. And why would I then want to touch it and ruin all that work? These are really cheap. I get these, one of the few things I actually buy at Harbor Freight. These gloves are great. They are awesome. They're cheap and they work great. Love them, and they're comfortable. So we're going to do that first. At some point you may see me put on one of these. It looks a little bit funny when I put it on. It's just so that I can see the work a little bit better. I may or may not. Sort of depends on my mood and how I'm feeling that day. Try to work without that so it doesn't get in the way. But they're great too. These are made by I'm not sure who it's made by, but it's called the Optivisor. I have a number 4 lens. That's the right lens, in my opinion, for this kind of work. The right magnification and focal length works really, really well. But I think Bausch & Lomb makes one that's even better. They're not cheap, but I think Bausch & Lomb makes a better one. Okay. So the first thing I'm going to do, here's my board. Okay. These boards are produced for me, at least at the moment, by Sunstone out in Arizona. They're great. They're reliable. They make great boards. Easy to work with. They're fast, and they're not too much money. You know, obviously a little more than heading over to China. I think if I go to China and order these, I can get them for like $1 each. Obviously these cost me a little bit more, but I think it's worth it. They just make a fantastic board. I've never had an issue. Okay. Well, the first thing I'm going to do is clean off this board. I've been handling it. It's been kicking around on my bench, and honestly, they actually don't really come all that clean. There's always a little bit of crud that I get off the board. So we're going to clean it with a little bit of IPA. Okay. There we go. And the first thing I'm going to do is I'm going to solder on a couple of diodes, because these diodes come fairly, yeah, you can see all the, I mean, if you think these things come clean, you see that dirt there? It's just coming off the board. Okay? You want to get that off. You really want to get that off. First thing I'm going to do, we're going to solder on a couple of diodes. And the reason I do these first is that these need to be fluxed. And they need to be fluxed because I don't know if you can see that, but they're not particularly clean. They're kind of oxidized. Sometimes you get them, they come in great. Sometimes you get them and they come in like that, and they need to be cleaned. So we're going to clean them. Okay. Or I should say that they need to be fluxed because we clean everything here. Everything gets cleaned. So the first thing I'm going to do is clean them. With the IPA. Again, all the cleaning we do except for the flux later on is going to be with IPA. Okay. And then because of how they fit onto the board, I need to make a couple of bends. A lot of the other ones I'm just simply going to bend by hand. With this one here, I'm actually going to use my chain nose pliers to make my bends. Okay. Nice bend, and we stick it onto the board. Obviously I'm going to be going a little bit faster than this when I'm building these in production, or it's going to take, it's going to take forever. nice and clean. At some point, I'm going to speed up a bit, but for right now, I'm just going to take it nice and easy. Okay, see what a nice bend that makes. See, there's no sharp edge in there. That's really what you want. That's really what you want. Now at this point, there's a couple things you can do. I think what most people would do, I'm not going to say this is bad or good, I'm just going to explain. Most people would do at this point, they would get these leads, they would bend them out to hold this in place. They would then come ahead and solder, right? And then they would come back and they would cut the leads off. That's not what we do here. I don't think that's the right thing to do. Certainly that would not pass a lot of specifications for high reliability components. The problem is when you do it like that, you run the risk of actually cracking the joint. Lots of specs will tell you that if you cut after you solder, you have to reflow the joint. And what they mean by that is bring the soldering iron back and remelt the solder, and you reflow the solder and basically remake the joint. Or you could also put it back through the wave solder machine, or you can put it through a reflow oven, which will heat the whole thing up and reflow the joint. However, you don't really ever want to do that without adding more flux. Anytime that soldering iron touches a solder joint, you don't get the best joint unless you have more flux. Now, as we talked about before, the flux is in the solder itself. There's a couple things you can do. You could either add flux to it and reheat the joint, or you could add a little bit more solder to it, which is what I would typically do if I ever needed to reheat a joint for a reason. I would just simply come back with a touch more solder. And that would actually add a little bit of flux to the joint. You know, as soon as the metal cools down and the flux has stopped doing its thing, it's going to immediately start to oxidize, and also the solder is not going to flow very well. So, okay, but you can do that if you want to. You know, you can bend them out and cut them. Or which I don't think is the right thing to do. Or you can bend them out, you know, or bend them, solder them, and then cut them. Or you can bend them, solder them, cut them, and then reflow the joint. I think by far the best way to do it is to actually cut these before you solder. And you can bend them out and then come in with the nippers and cut them. And we're going to do that later on for some caps. But when you have components like this that fit flat, there's a much easier way to do it. Much easier, much quicker. What we're going to do, you're simply going to take a piece of tape. I normally have this in a holder, but my tape holder is rather large because it holds like 5 or 6 different rolls depending on the width. I just wanted to get it out of the way. And we're simply going to tape it down. That's it. That's how you do it. You'll find aerospace guys doing this all the time. This is a great way to do it. You don't read about it much. You don't see it much. I don't know why. Fantastic way to do it. If you can do it like this, I highly recommend doing it like this. Really great. And then I'm going to come in with my little cutters here. I would normally hold them on the top, just a little bit to make sure that they don't go flying. In this case, I want you to be able to see what I'm doing. I'm just coming down, nip off. See, you can hear them probably hitting everything. I'm going to cut them off. Okay. And that's what we end up with. That's about what you want to see. Okay. Now remember, this guy's here came in kind of dirty. A little bit oxidized. That's what we're going to use this flux pen for. What I'm going to do, I'm going to apply, and you don't need a lot of flux, but in this case it really doesn't matter because we're going to clean it after this step. We're going to apply the flux. This is why I hate the pen. It's really a pain in the butt to get the flow going. Okay, and we're going to flux the top because the solder is going to flow through to the top. So we are going to flux the top. Okay. Okay, that's good. Now we have. You can probably see it. Maybe you can't, but now we have flux on the top and on the bottom. Okay. And now we're going to solder. Again, I'm going to speed up at some point, but I'm just trying to really show the steps here. When we solder, couple things you want to do. Number one, you want to make sure that your tip is clean, right? You want to be sure that your tip is tinned. By the way, when you put your iron back in the holder here, some people have the habit they go and they clean it off because they want to put it away shiny. Don't do that. The solder on the tip, get nice big globs on the tip if you're going to be in there for any amount of time. The solder on the tip actually protects the iron. It will keep it from corroding, and your iron will last far longer. This particular station, or the tip will, this particular station actually goes to sleep when you put the iron back in the holder. It'll actually reduce the temperature below the temperature, the melting point of the solder. But the thermal recovery on it is so good that after you take it out, it goes right back up. See, I'm already at temp. It goes right back up to soldering temp. So you hardly even notice it. So what I'm going to do, I'm going to come in. I'm going to put the solder down. Let's try to zoom in here. Let's see what we can get going. Let's see. Okay. Can I go even more? Yeah. What I'm going to do, I'm going to come in, and I'm actually going to put the solder between, it's like the corner of the solder between the tip and the joint. Okay? I'm going to quickly apply the iron to the joint, and then I'm going to move the solder to the other side of the joint and finish. So I'm going to start sort of like this, kind of start like this, and then I'm going to move to the other side of the joint, and I'm going to flow the solder in from the other side. What we're doing is we're creating a solder bridge between the tip of the iron and the workpiece. We're putting solder down, and that's going to conduct heat far better than just the solder tip, metal hitting metal. You know, or I should say solid metal hitting solid metal. As soon as that solder goes a little bit molten, it will conduct heat so much better. Okay, so again, we're going to make the solder bridge. Not a lot of solder. We're not soldering right now. We're just going to make the bridge, and then I'll move to the other side and I'll flow the solder in. Then I will remove the solder, and then I will remove the iron. Okay. I'm explaining this because it's going to go really fast. It's just going to take a couple of seconds. So I want to make sure you know what we're looking at here. Okay. So there we go. I cleaned it. Let's make a joint. There we go. Feed in the solder. Joint's done. Doesn't need a lot of solder. You can see now why I want a flat tip. Okay, I want the flat tip because I want to be able to get a lot of the tip in contact with the workpiece. Okay. Okay. Now the most important part, we are going to inspect our work. And what I'm looking for, let's zoom out for a second here. Okay. It looks like a mess now. We're going to clean it in a second. But what I'm looking for nice concave joints, you know, not big globs. And I also want to make sure that we flowed through to the other side really, really nicely. I'm going to look and inspect to see if we have any voids or anything that doesn't look quite right. Everything looks good to me. So now we're actually going to clean this. And the reason we're cleaning this, so with the Kester 44, you really don't have to clean it. You honest to God don't. Let me explain a little bit what happens when you actually solder. And you can't see it here because of the additional flux that I added, but the amount of flux in the solder itself is just right when you're doing everything right temps and correct speeds and things like that. What will happen is as soon as you touch the soldering iron and everything starts to melt, the flux itself will become acidic. And it will actually start to clean some of the oxidation off of the components. At the same time, it helps the solder itself flow much better. When you're doing it right, you will actually sort of boil. I'm not sure if that's really the right word, but you kind of boil all of the flux out of the joint, and it will dry on top of the joint or around the joint, and it'll sort of dry to this amber, and it gets pretty hard after a while. With this particular kind of flux, that's actually encapsulating anything that might cause any sort of corrosion down the line. Okay, so when you see boards and they have a bunch of flux on them, you know, as long as the flux isn't burnt, you know, and you'll see it sometimes, it'll be like a really dark brown or even black. That's bad. You don't want that. But if you have a nice amber color, you know, it's only a cosmetic issue. That's actually perfectly fine. I've spoken with the guys over at Kester. They tell me there's absolutely no reason to clean any boards with this kind of flux. That being said, when I add it by hand, I always clean it off because there's a lot of the flux around here that actually has not been properly heated. Okay, you really do want to clean that off. There's a lot of still liquid flux. Just you don't really want that. Okay, the general rule with cleaning flux is if you don't clean it right, don't clean it at all, because you will just make it worse. You will take all that stuff that you want to get off and you'll just squish it around all over the place. So you have to clean it right. At some point, I may bring an ultrasonic cleaner into the shop. I do still clean entire boards. I may actually clean this particular board here just so that you can see the joints a little bit better and have a good idea of what you're shooting for. In general, the only joint I clean is that one joint because I had to add the additional flux to it. Okay, so let's clean it. It's just a time-consuming step to clean the entire board. There's no reason for it, number one, and number two, it's actually a fairly expensive step. These particular chemicals are expensive. You know, they cost a lot of money. They cost a lot more money than you'd think. It's an expensive step too. What I'm going to use this Flux Off rosin. Works great with this little brush head. I'm going to tell you a little trick about that in a minute. I also have Flux Off with just a spray head. And then I have this Value Flux Remover, which is a completely different chemistry. This is an alcohol-based chemistry. What we're going to do is first I will scrub it with this sparingly, because the one with this particular head on it I think is like 2 or 3 times the price of that. And if you go and you look up this stuff online, I forget off the top of my head what it costs, but it's really not cheap. It's very expensive and it goes very fast. You know, I'm talking like $10, $25, something like that. It's extremely expensive for what it does. So we'll rub it with that first, then we'll blast off while it's still sort of dissolved with this. It's the same stuff, it just comes out in a spray so I can blast it off the board. And then we will clear off any additional residue with this alcohol-based one. You know, alcohol is a polar molecule. It will dissolve a lot of stuff that this may or may not really dissolve all that well. You'll find if you only use one or the other that you'll end up with residue on the board, and you don't really want that. Now, you can keep scrubbing with one or the other. It will eventually come off. But this is really the best way to do it that I've found. The trick, a little bit of a trick, is at this top here. These two cans are actually identical. Okay. However, once they put that top on the can, the price seems to double. But if you work hard enough and you empty it out, you know, what you can do is come in with a little screwdriver, pop off the top, pull the little thing off of this guy here, and pop this guy back on, and all of a sudden you have your new can. So this top I've actually reused now probably about 3 or 4 times. After, if you're careful, you'll get 4 or 5 things out of this. You'll be able to do 4 or 5 cans before you have to get another can. But that's a little trick. You can buy one of these, buy lots of these, which are far cheaper, and just remove the top. Now I will say that this top comes off hard. You're going to have to work at it a bit, but you'll get it off. Okay, so let's clean it. So in rapid succession here now, because you don't want this to dry between steps. Well, the trick here is we're keeping everything dissolved. We want it to stay dissolved, because if, say, stuff starts to dry before we're done, you're going to end up with residue on the board, which you don't want, because that residue is actually corrosive, and that'll cause you issues. This is why I'm saying, if you don't have to clean it, if you don't absolutely have to clean it, the best thing to do is just leave it alone, because it's not going to cause any trouble, okay? But for cosmetic purposes later on, we're going to clean the entire board. Okay, so just spray a little bit on. You don't need much. All I'm doing is dissolving it. Just dissolving it. Dissolve it on the back side. Now all that junk is still on the board. It just happens to be dissolved in that chemical. Now we blast that off. We've taken off most of it. Now we rinse it off with the alcohol solution. And that's it. This is going to come out pretty clean. When I'm doing the whole board, it's not really practical to dry it off like this. For that, we're actually going to use a heat gun to dry it off, or at least to finish drying it off. Okay. But when you only, you know, because the problem is, of course, there's a lot of components, and you can't really sneak this in, number one, and number two, on the back side, these are fairly sharp. It just tears, it just keeps on tearing, and it just makes a big mess. Okay. And then, of course, we're going to inspect our work. I'm looking at this, and these look like beautiful joints. So now that it's clean, you're going to be able to see what the joints look like, what the joints really look like. Okay? I'm not sure if you can see that, but you see those joints? They're beautiful joints. That's what you're looking for. There's not a lot of solder, just enough to flow through to the other side. Okay? Really nice. That's what you're looking for. Okay, now, those joints took forever. They can't keep on taking forever, of course. So we're going to speed up a bit now.